For more information on tutoring, personalized video solutions, or how to support Moof University and the production of more videos, check out moofuniversity.com. Thank you and enjoy. So in this video, I want to talk about the different types of chemical formulas that you will likely come across in your studying of chemistry. Okay, so when it comes to chemical formulas, the first thing we should do is define them. Okay, so a chemical formula is basically a combination of element symbols and numerical subscripts that denotes the type of atoms and how many make up the smallest unit of that substance, whether it's a molecule or a formula unit. For example, I've got 4 examples here. First one is H2O, which is water. A lot of people know that. Specifically, we've got the element symbol for hydrogen, which is that H, and a subscript 2, right, the numerical subscript 2 that follows it, indicating that there are 2 hydrogens. In addition, we've got the oxygen. Oxygen is represented by the elemental symbol O, and there's no subscript, which basically implies that the subscript would be 1. Okay, so what's really going on there is that's telling us that we have 2 hydrogens and 1 oxygen, right? 2 hydrogen atoms and 1 oxygen atom for every 1 molecule of water. And I say molecule because these are both nonmetals. Hydrogen and oxygen are nonmetals that are combined, and that's a covalent compound. Okay. Next up here, AlF3. So that's aluminum. There's Al is the symbol for aluminum, and there's no subscript, which implies 1 aluminum. And we've got F3. So that's fluorine followed by 3. There's 3 fluorines. And so we've got 1 aluminum for every 3 fluorines, right? But this is specifically an ionic compound because it's a metal and a non-metal. Aluminum is a metal. So there's 1 aluminum ion for every 3 fluoride ions. Okay. And so in every 1 formula unit of AlF3, okay, which is not a molecule, right? It's a formula unit. Okay. Next up, MgO, another ionic compound. It's got a metal and a non-metal. Mg is magnesium, so there's 1 magnesium ion for every 1 oxygen ion in a formula unit of the compound that is MgO. Okay. Over here, the last example, CO2, 1 carbon, 2 oxygens in 1 molecule of carbon dioxide. 1 carbon and 2 oxygen atoms in 1 molecule of carbon dioxide. Okay. So now there's 3 different types of chemical formulas. There are molecular formulas, empirical formulas, and structural formulas. So what does each one tell us? Let's start with the molecular formula. The molecular formula shows the actual number of component atoms of each element in a compound. Okay, so let me just use it. The best way to explain this is with an example, and I'm going to use the example of glucose for all 3 of these types of formulas. So the example is glucose. Now, glucose is a sugar, a monosaccharide. You don't need to know what monosaccharide means, at least not yet. But if you do, awesome. So glucose, I want the molecular formula of glucose. That shows me the actual number of component atoms of each element in the compound. So in 1 molecule of glucose, I have 6 carbons, 12 hydrogens, and 6 oxygens. In 1 molecule of glucose, that's what I have, right? And so this is the molecular formula of glucose, right here. Okay, that's the molecular formula. Next up, empirical formula. The empirical formula shows the lowest whole number ratio of atoms in a compound. Okay, and it's actually derived from the masses of the component elements in that compound. And we're not going to really talk about too many details of that right now. We're just going to talk about the definition, but that's something we'll talk about more when we talk about stoichiometry. Anyway, so if it tells us the lowest whole number ratio of atoms, then what would the empirical formula for glucose be? Well, I notice here that I've got 6 carbons for every 12 hydrogens for every 6 oxygens. So there's a 6 to 12 to 6 ratio. So if I think about 6 to 12 to 6, I notice that the greatest common factor of all of them is 6, right? So I can divide them all by 6, and I'll get a 1 to 2 to 1 ratio. And so the empirical formula would be C1H2O1, right? so CH2O. Okay, that would be the empirical formula for glucose, right? I just divided each of those numbers by 6. Okay, so that tells me the lowest whole number ratio of atoms, right? What about the structural formula? The structural formula shows the atoms and the bonds between them. So it kind of shows you the structure, the actual structure of the molecule. Okay, so if I know the molecular formula for glucose is C6H12O6, that means if I draw the structure, I should have 6 carbons, 12 hydrogens, 6 oxygens. So let's reveal what that looks like. Reveal all these atoms here as part of glucose. Okay. So let's just check it out. So this is the actual structure of glucose, at least when it's in its linear form. So I should have 6 carbons, 12 hydrogens, and 6 oxygens. Let's just verify that. So let's count the carbons first. Circle them in yellow. So we've got 1, 2, 3, 4, 5, 6 carbons. Okay, cool. That checks out. We've got 6 carbons. What about hydrogens? We should have 12. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. That checks out too. So last thing is 6 oxygens. We've got 1, 2, 3, 4, 5, 6 oxygens. That checks out too. Okay, so that's the actual structure of glucose. Now I kind of want to erase all those circles I just made just to indicate that, or just to make it less messy. That was just to sort of count the atoms. But also, those are all the atoms, but the bonds between them are important as well, right? There is this bond here connecting those 2 atoms. There's a double bond there. There's a bond here. There's a bond here. All these different bonds between these atoms. That's what the structural formula shows you in addition to the atoms themselves. It shows you the atoms and how they're connected. And that's specifically for glucose. Anyway, I hope that video was helpful. Thank you for watching. If you found that video helpful, don't forget to like, comment, subscribe, and share with friends. Thank you and happy studying.